If your team thought chemistry was already getting math heavy, stoichiometry might just be the moment they throw their hands up and say, "This is science, people, not algebra." But here's the truth. Stoichiometry isn't as scary as it seems once students understand that it's just a step-by-step process based on the mole. That is why this is part 2 of my 2-episode series on the mole and stoichiometry, 2 of the biggest challenges in chemistry. So if your team hasn't mastered the mole yet and you're looking for ways to help them, then go back and listen to the last episode first. Because in this episode, I'm breaking down stoichiometry step by step, what students need to be able to do, and share some strategies to help them feel confident solving these problems. Let's dive in. Welcome to Teaching High School Science. I'm your host, Doc, a former biochemist turned high school science teacher and private tutor. Whether you're homeschooling your teen through high school science or teaching online, join me as I share tips and strategies I've learned over the years for at-home and online labs and activities, breaking down complex concepts and structuring learning in a way that makes sense. Now, let's dive into today's topics. Now, the concepts that I am discussing may be a bit challenging to visualize in a podcast, so I am linking my YouTube tutorial videos as well as a blog in the show notes so that you can go read or watch, whichever you prefer, to help make these steps make sense. So first, what is stoichiometry? Simply put, stoichiometry is the math of chemical reactions. It allows us to predict how much product will form from a certain amount of reactant, to determine how much of a reactant is needed to completely react with another substance, and to analyze real-world chemical processes like cooking, medicine doses, and even things like fuel efficiency. In a nutshell, it's allowing us to convert substance A to substance B. And since stoichiometry is about using mole ratios from a balanced chemical equation to make these conversions, if your student don't understand the mole or feel confident in the mole, then stoichiometry is going to feel absolutely impossible. So I cannot stress enough, if they do not have the mole or feel confident in the mole, go back to episode 24, grab that information, and then come right on back over here. Now, let's go over some basic steps that students must do in order to be successful with stoichiometry. And these are the steps, the core steps of any stoichiometry problem. Some of them may have some little extra stuff, but if they got this core, they can likely figure out the other stuff. The first thing is always, always, always start with a balanced chemical equation. So before doing any math, the chemical equation must be balanced. The coefficients in a balanced chemical equation are then used for the mole ratio. And that mole ratio tells us how substances relate to each other in the chemical equation. For example, the synthesis chemical equation for water has 2 moles of hydrogen reacting with 1 mole of oxygen to form 2 moles of water. And this is important because if we need to convert between oxygen and water, we have a 1-to-2 ratio. That's 1 moles of oxygen for every 2 moles of water. That is what we mean by the mole ratio. We use the coefficients in the chemical equation in order to determine the relationship between the substance we want to convert from and the substance we want to convert to. The second step is to identify the given and the unknown. Every stoichiometry gives a starting amount of a substance and its units. It can be 2.5 grams of water, 2.5 moles of water, or 6.022 times 10 to the 23rd particles of water. And it asks for an unknown, which is another substance. An example question can be, how many grams of water are produced when 4 moles of hydrogen gas reacts completely with oxygen? The given is 4 moles of hydrogen gas. And I know it's the given because it's the only thing in the problem that gives me the amount and the units and the substance. And then the unknown would be grams of water. It is important for students to write these down before they start because this will help them to set up the problem, service their map, and keep them organized as they're going through the steps. The third thing is to use the mole ratio from the balanced chemical equation. Now, this is an important part of stoichiometry, and it's this step where students often freeze. Sometimes they forget what they're supposed to do, and sometimes they know, well, I need to get hydrogen to water, but what do I use? If they're converting different substances, meaning from one substance to another, always use mole ratio. If they're only converting units, then they're going to use one of the processes we learned in the last podcast. And it's important for them to understand that they can only convert one at a time, either convert units or convert substances. Okay, so you may be getting an idea of what makes them frustrated and want to pull out their hair when they're working stoichiometry problems. And to really bring it home, let's go through one. For example, when converting our 4 moles of hydrogen to water, if I go back and look at the chemical equation, I see that I need 2 moles of hydrogen in order to form 2 moles of water. So that is going to be my mole ratio. Since I want to cancel out hydrogen, they will need to set that up in a dimensional analysis so that they're canceling moles of hydrogen and leaving moles of water. So this 2-to-2 ratio between hydrogen and water will have 2 moles of hydrogen at the bottom and 2 moles of water at the top. If you're mentally overwhelmed, imagine what they're experiencing at this point. Here is a strategy that I use with my teens that struggle the most with this, with understanding which way to enter the ratio into a fraction. I will have them write both fractions for the mole ratio even before they plug it in, meaning I will have them write 2 moles of water over 2 moles of hydrogen and then 2 moles of hydrogen over 2 moles of water. Having that written out provides them with a visual that they can better see which one to use in the setup to cancel out whatever they need to cancel out. That is a tip that tends to help them gain more confidence. And as they do more of them with this strategy, they realize they don't even have to do it anymore. Now, step number 4 is to convert moles to grams. In this problem, we're not given 4 moles of hydrogen and asked to find the moles of water. We are asked to find grams of water. Once we have done the stoichiometry part of it, which is converting one substance to another substance, then we check our units. If we have to go from grams to moles, then we use molar mass. If we're given particles of one substance or asked to find particles of another substance, then we use Avogadro's number, just like we did in episode 24. So in this case, we're given moles, we use our mole ratio, we found moles of water. Now that we have moles of water, we need to convert that to grams of water. So we would use molar mass. And remember, if your teen is having that difficulty understanding which go at the top and which go at the bottom, grams or moles, go ahead and have them write both of those fractions. And then they will see that in this case, moles go at the bottom because we want to cancel out moles and leave grams. Now, here are some common struggles. And these are things that I find my teens will skip, or I have to slow them down and make sure that they're incorporating these steps, and how to overcome these challenges. One is skipping the mole ratio. And that goes back to what I mentioned before, where they will write down the given. They would know they need to go from that substance to another substance, but they forget that they must use the mole ratio to convert substance A to substance B. And this brings me to the second common struggle, which is forgetting to balance the chemical equation. Make sure they double check, triple check that that equation is balanced. If not, they will use the incorrect mole ratios and they will not have the correct calculations in the end. The next thing is confusing the units. So it is very important that they don't just write the values, that they write the units and the substance. For instance, don't just write 4 or 4 moles. They need to write 4 moles of hydrogen because in stoichiometry, we're converting between different substances and in some cases, different units. And the last thing is not completely writing out every step. They get confident and they start skipping steps. That is when I have the most common mistakes, the most points being lost to the abyss of just forgetfulness or skip steps, because chemistry is already tricky enough, and writing out each and every step will help them to stay organized. Now, you may think, well, once they get through the mole, once they get through stoichiometry, that's it. No. This is a foundational skill for several things that they will be doing for a good minute. First, they need to understand the mole in order to be able to do stoichiometry. Then stoichiometry is needed for limiting reactant, percent yield, solutions, and gas laws. And depending on what all your student is doing, it may be needed for more. So understanding these procedures and concepts now will go a long way for many units to come. Is stoichiometry challenging? It absolutely can be, but it doesn't have to. When students follow a step-by-step process, it becomes a lot more manageable. And that is why I recommend, just like with the mole, that they write down the steps they use to solve different types of problems. One type may be from going from grams of one substance to moles of another substance, or from particles of one substance to moles of another substance. Also, from grams of one substance to grams of another substance. Each of these require a different combination of steps, but at the center is always mole to mole conversions using mole ratio, and helping them to see that will help them to make it all make sense. I want to remind you that if you want to have a visual of what we discuss in this podcast, then visit my show notes. I have linked my blog and tutorial videos that will provide step-by-step visual instructions that can help you guide your team. Also linked is my free calculator guide, just in case your team is still struggling or losing points to the scientific calculator. And the next time your team say this is science, not math, remind them that chemistry is just math with meaning. Let me know if you have any questions, ideas, or other experiences that you'd like to share. Head on over to my podcast page, which you can access by visiting my website at thesciencementor.com. Then select podcast from the menu and subscribe now to the Teaching High School Science podcast for your regular dose of motivation and just-in-time science ideas. And together, let's make high school science a journey of exploration and achievement. Until next time, remember, curiosity leads to endless possibilities.